The final task that we had for the July task was task 4, where I gave you guys a spreadsheet with constant discharge rate test data and results. And I asked you to complete the table where you had to analyze for transmissivity using a method of your choice, either in FC or Aquifer Solve, whichever program you had a preference for. And then determine the type of aquifer based on the drawdown curve as per Chrisemon and Derrida. And then comment on any additional observations made based on the data sets. For example, your recharge boundaries were intersected or a flow boundary was intersected. Now, I'm just going to go through one example to go through to the transmissivity, then the drawdown curve interpretation, and then any additional information from this. So to start off with, we're going to do borehole OWP8. So the data that I gave you included the drawdown data, the recovery data, and then my consolidated data. So this is my drawdown pumping data up to 360 minutes, and then my recovery data from 361 minutes to the end. So I'm going to just put this on my clipboard so long, and then go to Aquifer Solve. Start a new project, pumping test wizard, single well test. We've only measured drawdown in my pumping well. Go through, make sure my length time is meters and minutes. My pumping rate I've measured in liters per second. And then in order to get my transmissivity in meters squared per day, I need to define my conductivity as meters per day. And next, you can just put in this information if you want to. I'm going to leave it blank. My aquifer saturated thickness, we assume is bigger than my maximum drawdown. So I'm going to make it 28. Leave your anisotropy ratio. You can type in your well name here if you want to. It's a full penetration well, we're assuming. Leave this as default. Okay, so my pumping rates, I'm going to insert a row. So from time 0, I used a pumping rate, an average pumping rate of 1.32 liters per second. So 1.32. And then my pump was switched off at 360 minutes. So from 361 minutes, my pumping rate was 0. Okay, so from 0 to 360 minutes in my observation data set, I was pumping at 1.32 liters a second. Then in my observation data set from 361 minutes, I'm pumping at 0. Okay, then you just paste your data. You can delete this top row, it's blank. So you can see there, minute 1, my drawdown was 6.2. We say next and finish. You'll see it says no errors detected in data set. So I'm going to change this to displacement time. And I've got my curve here. So I'm going to choose the solution for a confined aquifer, Cooper-Jacob. And then this is most likely well bore storage. So I'm going to fit it onto the stable part of the graph or the long part of the graph over here and get a transmissivity of 7.26 meters squared per day. So that is part A, so 7.26. Part B, I asked you to determine the type of aquifer based on the drawdown curve. This is based on Chrisemon and Derrida, where you have this curve in the log-log graph for a confined aquifer. Unconfined aquifer with a delayed yield has this kind of curve, and then a leaky aquifer has this kind of curve. You see that similarity in the leaky aquifer in the log-log, but in linear log, there's a very different signature to your confined aquifer. Okay, so I've plotted my drawdown data on a log-log graph, and you can see it's got a curve similar to both a confined and a leaky aquifer. So then to make sure which kind of aquifer I have, I look at my linear log graph, and I can see there, it looks more like a leaky aquifer. So it is a leaky aquifer type. Then the final question was to comment on any additional observations that you made based on the data set. You know, did you see these kind of curves for a confined fractured aquifer or dual porosity aquifer? Pumping well in a single plane or vertical fracture, or a pumped well in a fractured dike? Yeah, I don't see any of those curves here. And then here, is there a recharge boundary? Potentially. You know, you've got the flattening curve, but not flat. But there isn't a barrier boundary. So that is how you would do those kind of things. So you can do the same for all of the other ones. And then we can look at our answers here.